In today's video, we'll be covering a very special data structure called span. It is designed to represent a contiguous region of memory, allowing for efficient and safe manipulation of data without the need for unnecessary copying. Spans are especially useful when working with low-level memory operations, like parsing data and improving the performance of code that deals with arrays or buffers. So here we have a very simple example. You can see an array of numbers 1, 2, 3, 4, 5, and here we are creating a collection of span of type integer. So we are saying span int and then numbers span equals new span, and we are passing this array over here. What we can do over here directly is take numbers, and instead of this line we can just go in and say numbers is an array. It will be directly converted to number span. And over here we are saying numbers in the array, and then we are looping through. But note what different we are doing over here. If you see this line 14 over here, so in this code we are using unsafe.add to access the elements in the numbers span. The unsafe.add method takes a reference, as you can see over here, to the starting element, in this case number span 0. So the first element that we have over here is being passed as reference, and an offset of I to access the desired element. So the reference has been passed, and then the index position is also being passed to access the element. It's important to note that working with unsafe.add bypasses some safety checks. So you need to ensure that you stay within the bounds of the span or array to avoid accessing memory that doesn't belong to it. While unsafe.add is faster in most of the scenarios, it's not recommended unless you have a strong need for low-level optimization and are confident in your understanding of unsafe code. In most cases, using a standard for loop or a for each loop is sufficient and safer. So that was one way where you can make use of span to iterate much quicker compared to for and for each when you're making use of this unsafe.add with references. Now let's run this one to see it in action. And here you can see it says numbers in the array 1, 2, 3, 4, 5. So it's working properly now. Some other use cases that we can take up as far as span data structure is concerned could be related to string parsing. So here let's comment out this piece of code, and I'll be writing another example over here. And here if you notice, what we are doing is, let's say we have a string containing a series of comma separated values, and we want to parse and sum the integers. Using spans we can make this operation more efficient. So in this example that we are looking at right now, we are converting the string into a read-only span of characters to avoid creating intermediate substrings or character arrays. We then use various span methods like over here index of and slice methods to efficiently parse and sum the numbers. So now using this approach, when we run this, the output will be 15 as we have over here, and you can see the output coming up over here as well. Sum of numbers equals 15. So that was another example where you can make use of span data structure to efficiently process or parse strings.